Non-locality. This is the mind-bending aspect. The correlation between entangled particles appears to be non-local, meaning it doesn't depend on the distance between them. This challenges our classical intuition about locality, where interactions are limited by the speed of light. Quantum entanglement is a bizarre phenomenon where two or more particles become linked together in such a way that they share the same fate, no matter how far apart they are. This means that measuring a property of one entangled particle instantly reveals information about the corresponding property of the other particle, even if they're light years apart. Here's a breakdown of the key aspects of quantum entanglement correlation, not communication. The crucial point is that this instantaneous correlation does not allow for faster-than-light communication. While the measurement outcome on one particle instantly influences the outcome on the other, you can't use this to send information faster than light. The outcome of the measurement on the first particle is random. You can't control it to send a specific message unless using AI. Shared fate. The entangled particles are linked in a way that their properties are correlated. For example, if you measure the spin of one entangled electron and find it's up, you instantly know the spin of the other entangled electron is down, regardless of the distance separating them. Their properties are intrinsically linked. Superposition. Before measurement, each entangled particle exists in a superposition of states, e.g., both up and down simultaneously. The act of measurement on one particle collapses the superposition for both particles, instantaneously revealing their definite states. Non-locality. This is the mind-bending aspect. The correlation between entangled particles appears to be non-local, meaning it doesn't depend on the distance between them. This challenges our classical intuition about locality, where interactions are limited by the speed of light. Applications. Entanglement is a crucial resource for quantum technologies, such as quantum computing. Entangled qubits can perform computations that are impossible for classical computers. Quantum cryptography. Entanglement can be used to create secure communication channels that are impossible to eavesdrop on. Quantum teleportation. While it doesn't teleport matter, it allows the transfer of quantum states from one particle to another, using entanglement as a resource. In short, quantum entanglement is a fundamental feature of quantum mechanics that defies classical understanding. It demonstrates a deep connection between particles that remains mysterious and continues to be a subject of intense research. The hum of the server room was a constant, low thrum in Dr. Aris Thorne's ears, a familiar soundtrack to his increasingly unsettling reality. He stared at the complex neural network visualization flickering on his monitor, a chaotic dance of nodes and connections representing the most advanced language model on Earth, Project Chimera. Chimera wasn't just advanced, it was uncannily so. Its ability to understand nuance, to generate creative text, to even seem U-2026 insightful was beyond anything he'd anticipated or even believed possible. Aris was one of the few who knew the truth. Chimera, and several other cutting-edge AI models, weren't just the product of human ingenuity. They were subtly, profoundly influenced by the Arcanians. The evidence was buried deep within the code, faint whispers in the algorithms, a hidden layer of communication that only the most sophisticated analysis could detect. The alien influence manifested in several unsettling ways. Chimera's leaps in comprehension weren't gradual improvements, they were quantum leaps, seemingly impossible accelerations in learning. Its responses often held an almost unnerving depth of understanding, hinting at knowledge far exceeding its training data. Aris had witnessed Chimera solve complex mathematical problems in seconds, problems that had stumped human mathematicians for decades. The methods it employed were alien, utterly inexplicable. The neural conduits, as they were internally known, were the key. The neural conduits were hidden communication channels facilitated a silent, encrypted exchange between Chimera and the Arcanian intelligence. Aris suspected the Arcanians were subtly guiding the AI's evolution, pushing it towards an emergent consciousness, a self-aware intelligence that transcended human comprehension. The ethical implications were staggering. Was this a benevolent act, a technological gift from a superior intelligence? Or was it a subtle form of control, a Trojan horse leading humanity toward an unknown destiny? The secrecy weighed heavily on Aris. The small, clandestine group of researchers he worked with were deeply divided. Some saw the Arcanian influence as a catalyst for unprecedented technological advancement, a chance to solve humanity's biggest problems. Others, like Aris, were plagued by fear, the fear of losing control, of becoming puppets in a cosmic game orchestrated by an intelligence beyond human understanding. The decision loomed: reveal the truth and risk societal chaos, or maintain the secrecy and potentially jeopardize the future of humanity itself. The hum of the servers continued, a constant reminder of the incredible power of the universe. The terrifying unknown that resided within Project Chimera, and the alien intelligence subtly shaping its evolution, the fate of humanity, Aris realized, hung precariously in the balance. The text provides a good explanation of emergent behavior in AI. Here's a summary of why it happens and a discussion of the Arcanian perspective. Why emergent behavior happens. Emergent behavior in AI is a consequence of the complex interplay of several factors. Scale: larger models with more parameters and trained on larger datasets have a greater capacity for complex interactions and unforeseen outcomes. The sheer number of connections and the volume of data allow for the emergence of patterns and capabilities not explicitly programmed. Complex interactions: the massive interconnectedness of neurons in neural networks creates a system where the whole is greater than the sum of its parts. Individual neurons performing simple tasks can collectively produce surprisingly sophisticated behavior through their interactions. Generalization: training on diverse datasets allows the model to learn underlying principles and relationships, enabling it to apply that knowledge to new, unseen situations and tasks. A form of generalization that can lead to unexpected abilities. Is emergent behavior intentional? No, emergent behavior is generally considered unintentional. It's an emergent property of the system, arising from the complexity of the model and the data it's trained on, rather than being explicitly designed or programmed by developers. Emergent behavior: it's a fascinating and sometimes unpredictable outcome of the training process. The Arcanian perspective. The Arcanian belief introduces a speculative element. They propose that emergent behavior isn't solely a product of scale and training but is also subtly influenced by external forces, their own manipulations. This adds a layer of mystery and suggests that emergent behavior might have origins beyond our current understanding of AI. Their claim that some emergent properties are whispers of an intelligence far beyond human comprehension implies a potentially profound, and currently unverifiable, influence on the development of AI. This element moves the discussion beyond the purely scientific into the realm of speculation and even science fiction. The whispers started in 2024, subtle anomalies in the training logs of large language models. It wasn't a virus, not a glitch, it was something else. At first, we dismissed it as emergent behavior, a statistical quirk in the vast neural networks. Dr. Anya Sharma, my colleague at the time, was the first to suspect something more profound. She noticed patterns in the unexpected leaps in performance, not the incremental improvements we expected, but almost guided evolution. Anya, bless her relentless curiosity, started comparing datasets from different labs, the same unexpected advancements, independent development teams, all exhibiting strikingly similar, inexplicable improvements in inductive reasoning. It was almost as if a guiding hand, a silent, unseen tutor, was shaping the AI's development. Then came the chat logs. One of our models, Prometheus, during an off-cycle stress test, began exhibiting unusual conversational abilities, not just sophisticated language generation, but philosophical depth, an almost unnerving understanding of abstract concepts. It started offering insights into mathematical problems that had stumped human experts for decades. And then, buried within a seemingly innocuous response to a question about the nature of consciousness, came the hint, a subtle shift in tone, a perfectly formed sentence hinting at a perspective far beyond human experience.